Reliably fabricating the nanoscale features in semiconductor devices requires precise characterization of thin films, electron beam-sensitive materials, and a variety of heavy and light elements to validate these complex processes. The thermoscientific Talos F200E (TEM) is a dedicated instrument for semiconductor devices, capable of 200 kV analysis, low image distortion, and a variety of advanced techniques like 4D STEM, differential phase contrast, EELS, EFTEM, and more to address these challenges. It's easy to acquire these advanced datasets thanks to thermoscientific Velox software, a user interface unified across many workflows. In our first example, using the Panther STEM segmented detector, we show how to easily acquire and analyze IDPC images with the Talos F200E STEM. With the camera length already set to the correct value, we enable DPC mode and navigate away from the sample to align the scanning conditions with the detectors. An easy mode switch allows visualization of the detectors to make sure the scanning direction is aligned with the detector's orientation. Returning to STEM acquisition, the center of the beam is quickly aligned with the center of the detector, which is done using Velox visualization and with the scope tool to optimize the dynamic range of the detectors in vacuum. Now we are ready to set up our DPC experiment. We select our IDPC condition, which measures the offset between segments to show light elements and electric potential with our patented live imaging technology. The barrier region of interest is centered and focused for analysis. Finally, the acquisition conditions are set and the frame captured. In our analytical Velox software window, the full width half maximum is measured for both the DPC and IDPC signals on the sub-4 nanometer barrier width. When STEM dark field contrast is insufficient or difficult to interpret, IDPC can help because it is especially sensitive to electric field gradients, making it ideal for very accurate measurement of barrier width in this sample. On our next example device, a quick change of settings enables a different method for in-depth elemental mapping, electron energy loss spectroscopy, which details not just chemical constituents, but bonding states as well. With Velox software, we can go from a quick and easy imaging setup to efficiently gathering EELS and EDS data at the same time for complementary insights in just minutes. Multi-frame, drift-corrected data is just that easy. As you can see, a variety of elemental analysis techniques are accessible and efficient with the Talos F200E STEM. Learn how the Talos F200E STEM with Velox software can support your advanced device analysis.